All right, welcome everybody. Glad to have you here today. My name is Grant Fritchie. Welcome to the Redgate discussion. We're going to be talking today about database lifecycle management, DLM, database lifecycle management. Let's get going. As I said, my name is Grant Fritchie. This is my contact information. If you have questions after today, I would really appreciate you just getting in touch. I want to know what's going on, what you've got questions on. It can be on this topic or any other, especially anything related to Redgate, but anything else, database lifecycle management, query tuning, I'm into all of that kind of stuff. So anything you got going on, I'm willing to talk about it. Now with me today is Arneh Eskandari. Arneh, do you want to say anything?
Sure, yeah. Hi everyone, my name is Arneh Eskandari. I've been with Redgate for just over 5 years, and as a sales engineer I've worked with hundreds of customers helping them improve their database change management process by utilizing our solution. So here are my contact details. Please feel free to reach out if you have any questions on what we covered today or any other questions regarding your DLM processes.
Great. Now, if anyone has any questions during the broadcast today, there is a questions pane down below, over on the right-hand side. You should be able to see, and if you just fill out any questions you've got there, and then we will try to answer them as we go along. So please keep that in mind as we go. Don't hesitate to ask those questions because we want to make sure you guys get a good set of information out of this. All right, let's go ahead and get going. So our agenda, we're going to talk a little bit about Redgate software. We're going to talk about some of the challenges of DevOps and databases. It actually really is a challenge. There's just these nasty old things called persistence that gets in the way sometimes of agile database deployments. We're going to talk about database change management. We're going to talk about the benefits of DLM and DevOps. And then we're going to talk about how Redgate can help you achieve some of the better things out of DLM, and then we're going to go into a bunch of demos. So there'll be tests on this later, so make sure you've memorized this slide. We are moving on. Now, Redgate software, we are a nice little software unit, best way to put it. We get a lot of stuff done. We're working with lots of large companies. We work with lots of small companies, and we want to make tools that help. That is our goal. It's our goal in life. We want to make tools that help. We're really interested in sharing knowledge, sharing skills, and that's what we do. We run Simple Talk, which is one of the great publication sites. Lots and lots of great articles there on database development, application development, all kinds of tuning, all that fun stuff. We have SQL Server Central, which is the single largest collection of data pros on the planet working in and around the Microsoft Data Platform. And that is who we are. We are, as I say, we are about sharing knowledge and sharing abilities, and we make some pretty cool tools too. I just want to bring up that tomorrow and the next day, December 14th and 15th, we are going to be live streaming in the city. It's SQL live, streamed out over the internet. You can still register because it's it's online, so it's going to be pretty open. If you go to redgate.com/SQL in the city, you guys can register and come on in. I've got 4 different sessions tomorrow on several different topics, not DLM. So I'm going to be talking about some other stuff tomorrow. Although actually, I take that back. One of the things I will be talking about tomorrow is SQL Clone, and that is very much something that you can take advantage of with database lifecycle management. So I don't think we'll be addressing it today, so that means you've got an excuse to come tomorrow and listen to what I have to say. Let's keep going. So here's the thing. DevOps, development, operations, crossover, right? DevOps, the whole idea of development and operations meeting in the middle is vital to modern technology. I mean, it is the way we're going to be moving things into the future, and it's no longer just some watchword or some sort of buzzword that gets tossed around. It is how we're getting things done. The issue that you run into, though, is that data has to remain. If all we had to do was treat database like code, throw away the old code, put in the new code, then databases would be easy. The funny thing is businesses seem to like us keeping the data around. We have to preserve it. We have to protect it. We need to manage state between the upgrades, through the upgrades, and come out the other side with the existing software, updates to that software, and all of it working and functional and the data intact. So that makes things just a little more difficult for any of the data pros out there who are developing databases, any of the DBAs out there who are trying to maintain these databases. It just makes it all just a little harder. The thing is that we run into is that there's all kinds of issues. First off, databases just aren't maintained with the development packages. Development goes through its cycle and the databases go through their cycle, and those cycles are different. They're not maintained together, they're not run together, and that asynchronous methodology, that lack of connection between the application and the databases causes severe problems when you go to do deployments, because it's going to cause issues. The code doesn't match the database. Worse yet, the database doesn't match the code. And that's going to cause issues. You're going to cause data loss, you're going to cause data corruption, and all of this is going to affect your effectiveness in deployment. The whole thing when you're doing deployments is you want to be as smooth as you possibly can be. You don't want to have to worry about crashing things and tearing things down and not being able to know where things are at. One of the issues you run into with databases is a lot of people do ad hoc methodologies with their databases. The changes just kind of roll out. There's not a method of tracing what was changed. Not only are you not connected to your app dev, but you also don't even know what changes you're making inside the database. Further, the only method a lot of people have for database rollbacks is to restore an older copy of the database. But as we all know, when you've got a successful deployment or a semi-successful deployment, data is going to change, and you can no longer just go to a backup to restore to a previous version of the database. You've got to have some mechanism in place to do a rollback. Also, as things get very, very agile, as you start to see speed improving in the database, in the application deployments, the database can become a bottleneck. It can slow things down, and that can cause major issues, not just for the application team. That causes major issues for the business. And remember, this is all about the business. It's this whole idea of DBAs versus developers, of databases versus code. That's gone. We are about business now. Everyone is about business now. Both the DBAs, the developers, we are all part of the DevOps team. We are supporting operations, we are supporting development, and we're crossing the streams in a major way. So it has to be an agile process in support of the business. Databases can cause things to be, slower and more risky, because if you're doing long, slow deployments, then you're moving lots of changes. Whereas if you're doing agile, quick deployments, you're doing smaller sets of changes. And smaller sets of changes are inherently safer. Even as a pure DBA, you know that if you're doing testing and development, what do you want to do? You want to change one factor, run the test, see what happens. If it improves, great. If it doesn't, what happened, why? Change another factor, do the tests. Same thing with development, with deployments. You want to make sure that you're doing small, short, sharp deployments so that they're more successful and they're more, safe. Also, a lot of times we see manual processes going on, and once you've got a manual process in place, that prevents you from automation. Once you can't do automation, you can't do CI, which is continuous integration. And that's all about the idea of automating your deployments in order to automate testing, in order to automate validation in your dev process, not out to production, just in dev, in order to get a higher quality set of code in the development process. That's what CI, continuous integration, is all about. If you can start to automate, then you can move from CI into CD, continuous deployment. And continuous deployment is the method whereby you start to automate deployments right up to production, maybe not into production, but next to it. Either way, automation is the key. Once we can automate our deployments, we can automate our tests. Once we can automate our tests, we can automate our validations, and all of this will lead to smoother, better deployments, smoother, better development, and much, much better deployment and dev integration. And frankly, when we're doing manual deployments, it takes time. I remember when we used to do manual deployments, it would take us hours and hours to get it done. We frequently would have a multi-hour process, so much so that we would all go to dinner together, maybe even have a beer, and then come back in to finish the deployment. Once we finally started automating the process and got it down to we were doing 5-10 minute deployments to production, successful every time, we were kind of bummed because we lost our dinner out. It wasn't quite as much fun. However, it served the business better. So the whole idea here, again, is to get back to the business, serve the business. So poor database deployments causes all kinds of issues. So what do we want to do? We want to go to DevOps. We want to integrate through a database lifecycle management with our application developers. If the app guys have got a process, a methodology, then the DBAs and the data pros need to be working off that same app dev methodology in order to arrive at repeatable processes. Once we've got repeatable processes, we've got predictability. We know what deployments are going to look like. We know how things are going to go. By bringing in predictability, we start to bring in the ability to automate, and once we bring in automation, we've got efficiency because we're eliminating all those silly manual activities. You don't need to run a backup manually. That should be scripted, and further, it shouldn't just be scripted, it should be automated. It should be part of the process that you're taking care of these things, the snapshots, all of the other types of things that have to occur as part of your deployments. All should be automated. As you smooth these processes out, as you make them more of an automated process, then we begin to achieve speed. It's the smoothness that gets the speed. You can't simply go fast. You have to go smooth. You have to achieve accuracy and repeatability in your methodology, and then you will get speed. And as you get all of this, again, the automation, the smoothness, the speed, we're going to get a higher degree of reliability because we've got testing built in, because we've got underlying infrastructure that is a part of our deployment and development process. We're no longer dependent on trusting in our knowledge or trusting in our skill set, which of course we do, but we're trusting in our process because we've got a DevOps process in place where we are integrating between development and operations, and because we are automating that process, and because we are validating all of our checks and our constraints and our tests, we can rely on the process to ensure our uptime and ensure that what we're releasing is better, just better. And that's the whole goal of trying to get to this. So the 2016 State of DevOps report, great read by the way, you should check it out, found that what's going on is that once you've got version control and continuous delivery built into your organization, you start to see higher IT performance. It's not simply that we're not fighting with the devs anymore. It is literally we are supporting the business better. High-performing IT organizations are more agile, and agile means faster, able to move quickly with the business in support of what they need. And so places that have these are able to deploy code faster and with a lower failure rate, which is great. And frankly, if you get better at IT, your business makes more money. And that's, to a degree, that's what we're down to. I mean, we want to make money for our business. Hey, look, at this time of year, you want to bring home that Christmas bonus, right? Getting automation in place, getting a more repeatable, faster process is much more likely to get you that. I definitely suggest you guys check out this report. So that's the idea, right? It's simple, it's straightforward. We want to achieve DevOps. We want development and operations to work together to automate these processes, to smooth out these processes. We want development and operations to achieve a mechanism of automated testing, automated deployment, automated validation, all through a source control system, so we have a known state other than production, and so that production is in a more known state. All of that stuff. That's what we're going after. So, how can Redgate help, right? That's the question. Well, here's the deal. We've got a whole series of tools built right around this whole idea. We believe in development and operations working together. We believe in DevOps. It is absolutely a fundamental part of what we do. So as a developer, you're starting over there on the left, you're working on your code, you're working on your databases, and you're checking everything in and out of source control together. As it moves in and out of source control, we're helping you out with tools such as SQL Prompt to help you write the code, SQL Source Control to help you manage that code in source control, and SQL Test, which is an automated, integrated testing mechanism that builds into all of that. Your code in and out of source control. Oh, and by the way, we plug right into the tools that you're using today. You're working inside of Visual Studio, we support that. You're working inside of SQL Server Management Studio, we support that. And these tools will allow you to work across all of these different tools with the same teams. So the DBA may be working inside of Management Studio, but they're checking code in and out of source control the same as the Visual Studio people are. All of that's going on. In the meantime, whatever source control system you're using, I don't care. TFS, great, good stuff. Git, even better. Get through TFS, better still. We support all those. Vault, Perforce, Subversion, Mercurial. Every one of these things is supported through this process. So you check stuff in and out of source control, that triggers continuous integration deployment. Again, the continuous integration deployments through Hudson, Cruise Control, Jenkins, my favorite, Team City, although I'm starting to fall in love with the Visual Studio team, the Team Foundation build. It's growing on me slowly. I'm not, I won't say I'm crazy about it yet, but it's getting better, I think. And we support this through DLM processes. All of these then can circle back, and they work with SQL Test. All of them work with SQL Source Control. Again, we've got the support all the way across. Now, your process goes through its release management. You're going to go through integration testing. You're going to go through quality assurance. You're going to go through a staging process prior to production. And you're going to use stuff like Bamboo or Octopus Deploy, again, or the Visual Studio release management. And they're going to produce an artifact. What's that artifact we're talking about? Hey, T-SQL script. The whole stuff goes out into production, and you're going to be able to get it out there into your production server. In the production environment, we've got a DLM Dashboard, which allows you to track changes. We've got SQL Backup, which allows you to manage your backups and automate your backups as you're going. And we've got a SQL Monitor, which allows you to keep track of what's going on in your server so that if there is some kind of issue that occurs during your deployment process, you can identify what's going on as you go along. Now, it looks like there's a question that's come up. Let me just check that. I didn't have that screen up. Give me 1 second. Sorry about that, guys.
Yeah, so the question is, does SSDT give me anything your tools don't?
Does SSDT give us anything our tools don't? Wow, that's an interesting question. Let me put it this way. I like SSDT. The first time I built this kind of process, I built it all through SSDT, and we built it successfully. So I'm not going to berate or beat up SSDT. It functions. It functions pretty well. But are there some things that our tools give you that SSDT does not? And the answer to that question is yes, actually. Let me just point out two. There's a bunch, but I'll point out two of the bigger ones. Number one, we work with Management Studio. SSDT is Visual Studio only, and you are stuck there. And if that's where you work all the time, great. That not a problem. But I know a lot of people spend a lot of time working in Management Studio as well as SSDT. So if you want to go for Management Studio, you can go in there. Now, in addition, I hope that didn't just come up on the screen, did it? My Slack thing. Anyway, that's one. The other big difference is we do data management. We have a whole data management suite allowing you to check in code tables and that kind of thing through your source control system. Again, don't go with millions of rows, please. Smaller data sets, right? Lookup tables, country lists, that kind of thing. but we manage that through a change control process. So just those two things, we do a lot better than SSDT. Again, I'm not trying to knock SSDT. SSDT works. So I would much rather you guys, honestly, I'd much rather you guys, had a working process than necessarily that you use Redgate tools. I'm just telling you, Redgate tools are going to make your job easier. That's all. But the key is that you have a working process. Any other questions, Arneh? Those will keep going.
Yep. So there's actually another one which
Okay.
so could you confirm if the Redgate tools work with Visual Studio Team Services?
Yes.
As opposed to the version of TFS. Yeah.
Yes. Yeah, we do work with TFS. Absolutely. Which is why we've got it on the screen there. All right. So just drilling down on development. Oh, I was supposed to drill down. Oops. Okay. So I already talked about development. What's going on is that when you start to work on these things, you're going to create these procedures, you're going to create these tables. They're all scripts, and they're going to go through your process. They're going to get checked into source control. Source control is going to fire a trigger, and that trigger is going to bring up the processes that allow you to do testing in a CI, continuous integration process. From there, it goes through DLM automation, again, using either release management from Visual Studio, Octopus Deploy, or Bamboo, and you're going to be able to generate these scripts, and you can gate these things and review them prior to deploying to production. You don't need to just throw them straight to production. You may want to. There's plenty of companies that do, but it really depends on your process and your needs. However, we support you if you want to go a script up to production and then do a manual deployment from there, or if you want to automate it straight into production. Either way, we've got tools that'll make that happen. And the idea here is that you're trying to create a script, right? I mean, the databases are still databases. I mean, nothing changes, right? It's still, whether we're talking SQL Server or something else, it's still just a database. And the things that are going to modify that database are the same scripts as you're used to running: alter table, create proc, drop index, whatever. Hopefully not drop index. That would be a bad change that we're making. Presumably, all the indexes we have in our production system are good, and we're only adding more where needed appropriately after testing. But that's my paranoid DBA talk coming out. Don't worry about that. Anyway, can't help it. It's still there. So we're going to be moving out these things all again through a script, through an artifact. The whole idea is that script is what gets run in testing, that script is what gets run in QA, that script is what gets run in staging, and then it's ultimately run in production. And the whole idea is that script is generated from source control so that you always know exactly what version you're deploying, you always know what branch you're coming from, and you're not coming from this act of discovery, but you're working through an integrated process with your dev teams. And we are up to the demo stage. It looks like it's your turn.
Excellent. Thank you, Grant. So,
sure. If everyone will bear with me, I'm going to change Arneh over to being the presenter.
Okay. And while you're doing that, Grant, I'm just going to run a quick poll to see how familiar everyone is with Redgate in terms of tools. So I'm just going to go ahead and launch that poll real quick. And in the meantime, I'll prepare my screen here.
Sure. I mean, I'm not a full-time DBA anymore. I do consulting on the side occasionally and do some work around here for Redgate, but I'll tell you, when I was a full-time DBA, SQL Compare and Data Compare were open on my desktop all day, every day. So those are the ones I had out. But then, yeah, SQL Prompts, oh my gosh, yeah, I love these tools.
Yeah, Compare Data Compare are the ones that we normally find a lot of people, being familiar with and using day to day. All right, so close to 60% voted. So come on, guys, let's get a few more votes in before we jump on the demo.
Yeah, it even says I can't vote, so you guys have to vote for me.
Okay.
All right, what's the results on this?
Let's go ahead and close that. So as you can see,
Ah,
most people are familiar with compare and data compare, which is no surprise at all.
right.
And we also have a good number of SQL Monitor prompt and SQL Source Control users, which is excellent.
Yeah, although I'm actually pretty excited that they don't know about DLM because that means they're going to learn a bunch during the demos.
Exactly, yeah, yeah, that's fantastic. All right, so let me go ahead and start sharing my screen here. Okay, so hopefully you can see my management studio.
Yeah, it's a,
So as part of Okay, fantastic. So as part of this demo, we're going to basically go through the diagrams that Grant just described. So we'll start off in the development environment, make some changes to our database, show you how our SQL Source Control plugin in SSMS helps you get your changes into your existing source control system. And once we commit our changes, then we'll go ahead and validate those changes through an automated build process using TFS and also deploying those changes across our higher environment. Again, all through TFS 2015. So the database that I'll be working with today is the Fabric and Fiber Dev database, as you can see here. So this represents my development database, so we'll make our changes to this database. And then I have 3 other copies of this database, which represent the higher environments that we'll be deploying to. Since everything's set up on my machine locally, that's the reason why I have all the databases on a single instance of SQL Server. So I'll start off by making some changes to our database here. So again, here is SQL Source Control, which is our plugin to SSMS, and it acts as a bridge between your development database or databases and your existing source control system, which is, in this case, is TFS. So the process of linking your database to source control is actually pretty straightforward. So if you pick a database that is not linked to source control, you can just go through the Setup tab, which is a nice, simple, easy wizard. So you just hit next, pick the source control system that you're working with, and pick the team project and the folder if you're using TFS, and go ahead and link it to source control. We also do support both dedicated database and shared database models. So dedicated meaning that each developer will be using their own copy of the database or their local sandbox, where shared is where developers make changes to the same shared database. So I'm sure Grant will touch on this in his session on SQL Clone a bit in SQL in this video as well. So, so let's go ahead and make some changes to our database. So I'll start off by some simple changes. So let's say we want to modify an existing object. So go ahead and modify one of these stored procedures. So I just want to add an additional column to this select statement. So we want to also return the, let's say the identity as well. And I'm going to go ahead and format it using SQL prompt and execute my change. So one of the principles of continuous integration is that you should treat everything like code. And as Grant mentioned, one of the benefits of using hours versus SSDT is that you can also source control the data that you put into your lookup table. So that's basically data that you make changes to in development, and you push that same data all the way to production. So I'm going to make a data change to one of my lookup tables. So your schema changes are source controlled by default, but your data is optional. So in order to link your data, you have to go to this link around static data option in SQL Source Control. And from here, you select the tables that are considered as lookup tables or reference tables. So in this case, I only have one table that is considered as lookup, which is this alerts table. And I'm going to add a new record to this table and push that change into source control. In the Object Explorer, you notice these blue blobs appearing. This is basically an indicator of objects that have been modified but are not in source control yet. So since I haven't committed my changes, those blue blobs will stay there until we go ahead and commit the changes to source control. So I'm just going to call this alert and make my change. So made a couple of changes. I'm going to go ahead and commit those changes to source control. You can either right-click on your database or just simply visit the commit tab here in SQL Source Control. And here you can see the changes that we need to commit to source control. So here's the store procedure that we modified. The bottom here, it shows you what's different between your version of the object in your development environment on the left side and what's already in source control on the right side. So we keep track of changes in create scripts, so we keep all your objects as create scripts in source control. So even if you modify an existing object, we go ahead and update the object definition in source control. That gives you a couple of benefits. One is that you can actually keep an audit trail of objects individually, so you can easily see how a specific object has changed over time. And when it comes to deployments, we rely on the compare engine to actually generate the update script based on the differences that it finds between our source control and the target environments that we'll be deploying to later. And for data, we store them as insert scripts. So here's the data difference. You can see all the records are identical, except that new one that we just added to our development database, and it doesn't exist in source control yet, so that's going to get checked in as well. I'm going to go ahead and write my check-in comment, which you would normally do. With TFS, we also have support for TFS work items. So as you can see here, you can just type in #A or #R, and the work item number to associate your change with a TFS work item. So let's go ahead and write our comments. So we modified USB get employees, and we added a new alert type. Okay, so I'm going to go ahead and commit the changes. So again, going back to what Greg mentioned earlier is, you need to make sure that you check in your changes, frequently. So if you made hundreds of changes and you check them all into source control at once, that doesn't really go with the principles of continuous integration, because when you run the build on 100 changes, a lot of things could go wrong in terms of errors or tests failing. So, and what that means is that you would have a lot of things to change and check into source control again. So you would have more downtime as a result of doing less frequent check-ins, because you would spend more time looking into issues and trying to figure out what you need to roll back. And so you're kind of, the more frequently you check into source control, the less likely you are to, go far away from a working copy of the database. So your feedback loop is faster, and you can easily find issues faster and fix them as a result. So now we looked into a couple of simple changes, right? But in databases, sometimes there are type of changes where you would need to also include some data to go with that specific schema change. So that's basically table changes. So column changes, adding a new column, not column to an existing table with existing data, and those type of changes where you also need some default data to go with that change. Now, for those of you who work with the compare tools, you know that the SQL compare only deals with schema. So if there is any data changes that go around that schema change, it won't be able to see those, and therefore that could cause deployment issues. So another additional things that we offer as part of our SQL Source Control is the migrations feature that you see here. And migrations actually enables you to override the default behavior of compare, and enables you to provide the exact script that you would need to execute as part of your deployment for a specific type of changes. So here I have an example. So we have this clients table, and if I look at my columns, you can see here I have these two columns, first name and last name. And let's say there's a new requirement to merge this into one single column called full name. Obviously, we have some existing data, so we need to deal with that as well and merge that data into the new column, which will be full name. So I'm going to go ahead and execute the script. So I already have a script saved up here just to save us a bit of time. So merge columns. So we're adding the full name as a nullable column. We're running an update to get the data from our first name, last name columns. And we're changing it to not null and drop the old columns. So everything looks good. Go ahead and execute that change. Now I'm going to go ahead and commit this change to source control. So we ran both DDLs and DMLs as part of this. So let's go ahead and try and commit this change to source control. And so the first thing you notice here is we get this warning icon here next to the change. So this is saying that these changes might cause deployment errors or data loss. And it says make sure that you write a migration script for it. So, which makes sense, right? Because when SQL compare runs, it will see that there is first name, last name that it needs to turn into full name, but it won't know what to do with the existing data. So that way, that's going to result into a deployment error. So to fix that, I'm just going to write a migration script. So you can see here again, it gives you the option to add a migration script. And there's two types of migration scripts that you can write with SQL Source Control. One is a blank script, which is mainly used for data migration. So if you have a specific data script that you want to go out all the way to production, then you can use a blank script here. But if your migration script is associated with a schema change that you need to commit to source control, then we recommend using this option here, because this will also go ahead and update the object definition in source control for you, as well as saving up the migration script that you write. So I'm going to go ahead and select the table that I want to write the migration script for and hit Generate Script. Generate Script will generate this the script that compare would try to run in order to apply their changes. So a typical compare behavior is to generate a temporary table, copy all the data and everything to that table, delete the old table, and rename the temporary one to the actual table. But this is not going to help in this case, because it still won't know what to do with data. So I'm simply going to replace that with the script that I executed in order to apply that change. And I'm going to save this as a migration script. Obviously, it helps to put if exists block around any migration script to make sure that the table or even the column that you're trying to modify already exists. So I'm going to go ahead and hit save and close on this. And now this is basically going to commit the change. So the table schema or structure hasn't changed. We're still going from first name and last name to full name, but the way you go there is now different, and we're using this migration script to do that. So SQL Compare would look into this and notice that there is a migration script that it needs to execute instead of its default behavior. So I'm going to go ahead and check in this change as well. So we merge first and last name into full name on client's table. And I'm going to go ahead and commit this to source control. Here it's just giving me another warning, but we already took care of that with migration, so I'm just simply going to acknowledge it and commit it to source control. What we store in source control again is basically the create scripts for the object. So here's the folder structure that we use in order to keep track of the changes that you need to make to your database objects. So you can see there's a subfolder for each type of object, and within each of these folders we have the create scripts for those objects. And we also have the custom scripts, which is what we use to keep track of those migration scripts that we also need to deploy as part of our deployment process. So every time I do a check-in into source control, that goes ahead and triggers a build to validate the changes that we make. So we offer a couple of extensions for TFS 2015 that makes it really easy for you to go in and configure your builds. So here if I go to my build definition, just to walk you through what steps we've put in to run a database build. So here's Fabric and Fiber build, and if I edit my build definition, here are the Redgate extensions that you can use as part of TFS in order to run the builds for your databases. Now you can have these alongside your application code builds or your MS build steps for the application code under the same project, or you could have separate projects for the database if needed. What we're doing as part of this build, the first step is build the database. So what this does is that it validates all the objects that we have in source control to make sure that there are no broken dependencies or any compilation or syntax errors. And then once that's done, then we go ahead and package up the files, so all those create scripts that we have in source control, into a NuGet package, which later can be used as a deployment artifact. So source of deployment to going to our higher environments. Once that validation succeeds, then we go ahead and run a set of automated tests on the database. So there are some integration tests and unit tests that you can automate using our SQL test tool and the two frameworks that we support as part of that, which are SQL Cup and T-SQL-T. If you look at my database here, I have a bunch of objects starting with the SQL Cup schema. These are some out-of-box tests that you can utilize that comes with SQL Cup in order to test some coding standards as well as some performance tests on your database. So for instance, here I've got some tests to
Arneh?
check for fragmented. Yeah.
Just let me interrupt you before you go going too much on SQL cop and the tests. I have an interesting question. Alex Frost asks, is there a way to source control data in multi-tenant environments? For instance, the situation is that there are multiple databases with the same structure, but they have static data that is specific to each. That was an
Yeah,
interesting
so
question.
those are, yeah, yeah,
I mean,
those
I
are,
have a guess if you don't have one.
yeah, so I was just going to say that that's definitely a tough situation because what that means is that you can't just have one copy of the data in source control, so you would have to have environment or database specific data to put in source control. So this default process of SQL source control would not work unless you have basically separate folders in source control for each of the databases, and then maybe use the command line of data compare outside this process to deploy those data differences based on which environment you're deploying to. But yeah, Grant, do you have anything
No,
else?
that's a good
I'm
suggestion.
sure you.
The other suggestion I would have would be branching for the data only,
Yeah.
and then like you'd have to have a two-stage process to do your deployments. Similar to what you're suggesting, you would branches for the data, and then a branch for the source code. And if the source code's all the same, the source code can get deployed, and then you'd have a second step that would deploy the data. I interrupted just because it was a really interesting question. I mean, and it's the
No,
kind of
totally.
stuff that that frankly, the fact that the tools are all PowerShell and command line driven, it allows you to a lot of versatility in how you could solve these types of problems. There's not something like literally inherently built in to solve that problem, but we've got flexibility such that we can solve that problem, and that's part of why I brought up that question. I'll shut up now.
Yeah, really good call. Awesome. Thank you, Grant. No. Okay, perfect. So yeah, so I was going through the type of test that you can automate through our DLM solution. So SQL Couplet's one of those. So there's these tests out of box that you can utilize. But the good thing is that this is all SQL. So if you want to customize any of these tests, you can just go in and modify these stored procedures, to meet your own requirements. The other framework is TSQL-T. Some of you may already be familiar with TSQL-T. It's a unit testing framework. It's a third-party framework. They have a website, tsqlt.org, where you can go in and learn a lot more about how to do unit tests on SQL Server databases. So here are the framework objects that you can utilize to actually create unit tests to test the functionality of your function store procedures or the business logic of your database. So in this case, I am basically relying on the SQL cop tests to run as part of this automated process. So since they're all basically considered as part of your database objects, they are checked into source control, and our test step will basically check for those type of objects and run those tests automatically as part of your validation process. And then I have two additional steps here, which in this case are disabled. So I have sync, which basically does a deployment, and it doesn't really apply to this demo because I'm using the release functionality of TFS to do deployments. So the sync is more relevant to cases where you have dev-specific branches and you have a main development database that you would merge into. So in that case, it would make sense to use the sync to update the main integration database, but it doesn't apply to our demo here. And finally, the publish, which is used to send the NuGet package to a NuGet repository. Again, since we're using the TFS stack, we don't need to send it the NuGet package anywhere else. So we'll just simply publish it as a build artifact, and our release process will pick it up. So now let's go back to our build and see what happened here. So you've noticed that my build actually failed. So let's go ahead and look into it and see why that failed. So there's the schema validation failed, and the first error that came out was invalid column name, first name, and the same for last name. So if you look further down here, you can see that it failed on this stored procedure. So what we've done as a result of that change that we made to the column is that we broke a dependency. So this stored procedure was dependent on the client table, and you can see first name and last name is no longer valid. So therefore our build failed. So what this means is that I need to go back into my dev environment, make some additional changes to make this build pass, and then we go from there. So I'm going to go back into my database, the development database, make the additional changes, fix those broken dependencies. So here's that store procedure that it complained about. And you can see here we have first name and last name. So we need to replace this with just simply full name. So here it is. And let's format again. Apply our change. And commit it to source control. So again, here's what we're committing. Here's the difference between our database and source control. Fix broken sprock. That should be good enough for the purpose of this demo. And go ahead and commit. So quickly, I'd like to run another poll just to see what source control system you guys are using or planning to use. Since this is a TFS, I'm assuming most of you are TFS, but I'm just going to go ahead and run that poll real quick to see which source control systems most of you are familiar with or are currently using. And in the meantime, that's my
everyone's using
right?
Git. No one uses anything else.
Yeah, pretty good.
No,
Very common, I'd say. Yeah, with looks like it's close to 50-50 between Git and TFS. With 70% have voted. So I'm going to go ahead and close it now. So you can see 10% Subversion, 52% TFS, 38% Git. And yeah, TFS and Git are definitely the two most popular source control systems that we see customers using out there. So, great. All right, so now let's go back to our build. And you can see that our build succeeded. Actually, it's still running, I think. Yep, so you can see our build actually succeeded this time around. So it means that we were able to build an artifact, which is that NuGet package from the changes that we made. So now the next step would be to go ahead and deploy those changes that we made to our hiring environment. So what we can do here is that we can go ahead and use the release function of TFS to do that. So let's go ahead and take a look at the release portion. So here you can see we have a release fabric and fiber. And again, we offer extensions on the release side of things. So going back to the question that Matt Davis posted regarding Visual Studio Team Services. So again, you can utilize these extensions as part of that. However, the only thing that it would be required is to have a local agent where you can install our DLM automation component, which would be utilizing these extensions. So that's really the main requirement if someone's using the VSTS as opposed to the on-site version of the TFS 2015. So what we're doing as part of our deployment process is that, first of all, we're creating the deployment report, which is basically the update script that would need to run, as well as a visual report of the differences between the NuGet package and the target database that we'll be deploying to. So what we do is that we run a comparison between the state of the database that is in your NuGet package and the target database, and it runs a comparison, sees what's different, and generates the deployment script as a result of that. Once that script is generated, then we go ahead and save it to network share for audit purposes, so we can keep a track of what we've deployed previously, and then we go ahead and execute that update script that we generate. And this applies to pretty much all of my environments for this demo. So I'm going to go ahead and create a release here. And for this release, we're going to take the artifacts from our latest build. So the most recent successful build was build 430. And I'm going to go ahead and create this, which is going to trigger a deployment to my testing environment automatically. So if I go to my releases, you can see my testing environment already started. It would be nice if TFS would actually show you which environment these bars represent, but we know that this is testing, and then staging and production will come later. So while we're waiting for the deployment to complete, I'm just going to quickly run another poll to see what CI systems you guys are using or planning to use or you're familiar with. Yeah, I'm actually wasn't a big fan of TFS until they released the 2015 version, and you know that was a massive change with some nice features built into both the build and the release side of things. So I actually like TFS now as a result of the 2015 release.
It's growing on me. I'm still a Team City fan, which puts me in the minority in this group.
Exactly. Well, yeah. Team City is obviously was one of the first build systems that actually was pretty user-friendly with a lot of stuff already built into it, so you don't have to build plugins around it and those type of things. So, and it's still one of the best out there. Yeah. So, yeah. So I'm just going to go ahead and close. And as you can see, we have a lot of TFS users, which is great. Jenkins is also another popular one, and we also have some Team City users in the crowd as well, so that's fantastic. So again, we do plug into basically any of these build systems. So we have plugins for some of them, such as Jenkins, Team City, TFS. For any other ones, you could basically utilize the PowerShell command list that we offer as part of our DLM automation to create your build steps. So now you can see my deployment to the testing environment failed. So let's go ahead and take a look at the report that we generated for this deployment. So just going to bring up this folder here, and if you look at the testing and take a look at the most recent deployment here. So there's a couple of things that we store in that report. So the report itself includes both the update script and the report of what objects are being deployed. So here you can see we're going from this NuGet package to our testing environment. And here's what's different. So there is the client table that is different. So we follow a Git style to show you how the object definition is changing. So this is not obviously the deployment script. This is just the object definition. I show you what's different. So we removed first name, last name. We added full name for the get customer store procedures. Again, we fixed that broken store procedure, so got rid of first name, last name, replaced it with full name. For get employees, we added that additional column to the select statement. And for the alerts table, we inserted the new record that we added. So all of these are encapsulated into a single deployment script. So you can, if you take a look at the script, here's what it looks like. So in order to keep track of what migration scripts are already executed on the target environments, we keep this deployment metadata table in your database, which basically is in charge of keeping track of what migration scripts are pending and what migration scripts have already been executed. So based on the comparison that we do to this table and the migrations folder in source control, then we figure out what scripts we need to run that you provided as migration script. So here is the first migration script. You can see this is the script that I provided as a migration script to cover the changes that we made to the client table. So instead of going with its default behavior, Compare just simply took the script that we provided to apply those changes. So here's our update script as well as the schema changes that we made to make those changes work. And then here's where it stops the migration script. And from this point onward, it's just going with its default behavior of comparing the other object and generating the script for him. And since this object already exists, we're running an alter for this store procedure, an alter for this other one, and finally the insert for that new record that we added. So everything's in one single script. It's easy to review, and again, if you are deploying small units of changes at the time, then you can see how easy it is to quickly review these changes, make sure they're all aligned with what you're deploying, and then just go ahead and approve it. Unfortunately, there's TFS doesn't have that manual intervention step built into it. They used to have it in release management, which was as part of TFS 2013, but for some reason they haven't put it in here. So what you could do if you want to have a manual intervention in place, you could break down your environments into two. So for instance, you could have one environment called testing code review, another one called testing deploy, where testing code review would run this step and testing deploy would run the second step of executing, and then you could have a review step in between the two. So we reviewed the deployment. Everything looked good. The migration, the update script looked good. So now I'm going to go ahead and, assuming that the test passed in the testing environment, I'm going to go ahead and deploy that to our next environment, which is staging. So go back to our releases, take the most recent release, and go ahead and deploy to staging. Since we're basically using everything as part of the TFS stack, the nice thing is that you can see all your change sets, so what commits are going as part of this release, if there's any work items, what work items there are. So you can see your user stories basically in the end-to-end process. You can create work items to go with the user stories and see exactly how those work items are being deployed as part of your releases. And that gives you a nice audit trail of what you've released and what you need to release next. So let's go ahead and deploy this. You can already have the approval steps as well. In this case, it's automated. And that's going to go ahead and trigger the deployment to our staging environment. So what we're doing now is running another comparison between the NuGet package and the staging environment to generate that update script and execute the update script on our target. So my environments are all the same. So what that means is that the update script will be the same going all the way to production. But sometimes you could have, scenarios where, let's say, testing is a couple of versions ahead. So you've done 2 deployments to testing but haven't deployed them to staging yet. What that means is that staging, when you deploy to staging, that will include the incremental changes going from both of those deployments that you did to testing into a single release. So that's one of the reasons why we do comparisons every single time, but that's optional. You could just generate a script once and execute that same script all the way to production without having to do any comparison. So the process is totally customizable, and you can either just use our extensions or even use PowerShell commandlets and some PowerShell steps to customize it for your own needs. So yeah, again, you can see the deployment to our staging succeeded, and we store a report similar to that of testing for our staging environment. And here's what it looks like. We also keep track of the states that your databases were at the point of deployment. So this is the state of our the database from the NuGet package, and this was the state of the database at the point of deployment before we actually executed. There's a couple of reasons why we store this. First of all, the main reason is to detect drift. So if a database change was introduced to your database from the point where we ran the comparison, then the deployment will fail at the point of execution because your database is no longer at the state that it was when we ran the comparison. And then we do another comparison after deployment to make sure that the changes have been applied successfully, which are called our pre-deployment and post-deployment schema checks. So we're almost running out of time, but that's pretty much basically the end-to-end process of utilizing our tools, going from dev all the way to deployments to production. So I can see that some of the questions, or actually most of the questions, have been answered by Grant. But if there's any additional questions, Grant, that we need to answer at this point?
Not that I can see. I've been taking care of them right along, most of them. So I'll launch the last poll. I'm just curious what kind of release management tools you guys use, if any. most of you guys are using Visual Studio Release Management, and then a lot of you are using Octopus Deploy, which pretty much is what I expected to see. All right, you should see the demo screen. All right, so thanks everyone for attending, but I really want to make sure if you need some help, if there's any questions outstanding after today, after what we've gone over, please reach out and get in touch with us. You've got Arneh's contact information, my contact information, and here's DLM@redgate.com for any kind of follow-up you want to get to. And thanks for attending, everyone.
Yeah, thanks everyone. Thanks, Grant.